Question 29. When populations with separate ancestors adapt in similar ways to similar environmental constraints, so similar selection pressures, it's referred to as convergent evolution. And question 30. Which owl was most fit? The owl that has the most young to leave the nest would be the fittest. So therefore, A, owl who lays 8 eggs, 6 hatched, 5 young, successfully left the nest is the fittest. Okay, I hope you did well on the multiple choice section. Give yourself a number out of 30 for that one. And then let's have a look together at the short answer quickly. Section B, short answer, question 1. Nocturnal worms have the selection advantage because they're avoiding predation by only coming out of their burrows at night time. The selection pressure being predation. So the selection pressure is what causes something to live or die. So in this situation, it's predation by the bird. C, would any in the next generation be diurnal? It's hard to answer a yes or a no to that, absolutely. However, the majority of the next generation would in fact be nocturnal because these are selected for, and the diurnal are selected against because the diurnal are more likely to be eaten by the predators. But it's very difficult to say that no diurnal worms would survive. The key marks there are talking about the selection for and selection against those two behavioural phenotypes, okay, those two adaptations. D, what would determine whether these worms belong to the same species or not? So if they can reproduce and have fertile offspring, then they are in fact the same species. If they cannot reproduce or their offspring are infertile or non-viable, then they are in fact not the same species. Answers regarding molecular comparison of the two worms or hybridization wouldn't really give us a yes or a no answer to whether they were the same species. It would tell us how similar they are and how many mutations have occurred in each. Might even tell us the location of the variations in the two types of worms, but not. Remember that the definition of a species is that members of that species can reproduce and create fertile offspring. Okay, so that's what the question was getting at. E, if they do belong to the same species, outline the steps in the process that could occur leading them to become two species. So we're describing divergence here, okay? We've done this in class and hopefully you've had a go at some of the past papers. So you know that we need variation, we need isolation. So if variation occurs but the populations continue to mix, then speciation or two different species will not occur, okay? Because you'll continually mix up all of the genes and all of the alleles and just have lots and lots of variation in your population. You actually need those two populations to not mix, and an accumulation of differences over time would cause them to be different and different enough to no longer be able to reproduce and have fertile young. Okay, so it's important to say that again. That's the final end point in them becoming two different species, is that they can no longer interbreed. How can scientists determine the age of rocks and fossils? Describe two ways. So there's relative dating, which we've discussed, things like stratigraphy, so that using the layers of rock and knowing that rock or fossils lower down in the strata are older than those up higher. And then there's also the specific dating techniques, using isotopes to date rock, such as potassium argon dating. And that can give you a very specific indicator of how old potentially some volcanic rock is in the layers. Okay. Specific dating of fossils, you could use carbon dating if there was still some carbon left in that fossil, assuming that it wasn't too old. So I've put carbon-14 dating if it was less than 50,000 years old. So really I just want you to give one example and a reasonable explanation for each. And here, question 6, State and describe briefly how fossils and comparative anatomy provide evidence of evolution. So for 2 marks, you need to be able to explain how fossils give us evidence of or show that evolution has occurred. So the idea that species are changing over time and they come from more simple organisms and they become more different as time goes on. I've put some examples in here. So I've said that fossils show increasing complexity of living things over time, and some fossils indicate the transition between major groups, such as the transition fossil that we looked at, going from reptiles to birds. But any reasonable description there would be a good one and may well get you the 2 marks. Comparative anatomy shows us that organisms have similar structures and structural features, such as the limbs of the bat and the human and the cat that we looked at in the skeletons. And it indicates common ancestry. Okay, so one common ancestor has then diverged into a variety of different mammals, for example. But we're able to identify that by actually looking at these homologous structures and noting that despite different functions, the bat's wing and the whale's fin and the human arm have lots of similarities there. Okay, that is your last question. So please sum your score for section B. Ensure that you've annotated each question fully so that you've got the best possible answer on your own paper, so that when I give it back to you, you can use that for revision in the end of the year exams. And I would really like you to open your notebooks and make some notes on the areas that you think you were strongest at and those that you feel you have more work to do, such as, do you understand the concepts of natural selection? Can you differentiate between genotype and phenotype? Is your terminology strong enough? Do you have a good grasp of the evidence of evolution that we've looked at? Have a look through your paper and make a few dot points to help you focus your revision towards the end of the year. Have a great time next week. I hope you enjoy whatever you're doing, and I will see you in term 4. Please email me if you have any questions at all, and have a good weekend.